Ever wondered why cars and bikes don't just topple over when they take a sharp turn on a bend road? The answer lies within the fascinating world of physics. Consider the scene. A car speeds down a highway, approaching a bend. The driver turns the wheel, and the car gracefully arcs around the curve. It's a common occurrence, but have you ever paused to think about the forces at play? It might surprise you to learn that the reason cars and bikes don't roll over during a turn has much to do with the interplay of gravity, inertia, and the centrifugal force. To understand this, we first need to delve into the concept of inertia. According to Newton's first law of motion, an object in motion tends to stay in motion along a straight line unless acted upon by an external force. This is inertia. When a vehicle rounds a bend, inertia wants to keep it moving in a straight line. However, the wheels of the vehicle, which are in contact with the road, provide the external force needed to change the direction of the vehicle. Next, consider centrifugal force, often described as a fictitious force. It's the outward force that appears to push a rotating object away from the center of rotation. When a vehicle turns, the centrifugal force acts horizontally, perpendicular to the direction of gravity. It's this force that gives you the sensation of being pushed to the side when you're in a car taking a sharp turn. But why doesn't this force cause the vehicle to roll over? The answer lies in the vehicle's center of mass and its relationship to the ground. The center of mass of a vehicle is a point where it balances perfectly. For most vehicles, manufacturers design them such that the center of mass is quite low, closer to the ground. This low center of mass, along with the wide base provided by the wheels, creates a stable situation where the gravitational force pulling the vehicle downwards is much larger than the centrifugal force pushing it sideways. Bikes, on the other hand, have a much narrower base and higher center of mass compared to cars. However, they manage to stay upright during a turn due to a phenomenon called countersteering. Simply put, when a biker leans into a turn, they momentarily steer in the opposite direction. This action creates a torque that counteracts the effects of the centrifugal force, keeping the bike balanced. In summary, it's the intricate dance of inertia, centrifugal force, gravity, and clever design that keeps our cars and bikes from toppling over when taking a bend. The vehicle's center of mass and the driver's skill in handling these forces play a crucial role in maintaining stability. So next time you're cruising down a winding road, take a moment to appreciate the physics at play that keeps your journey smooth and safe.